So to start off with, what we found is that there's a lot of folks out there who want to really get the power of something like Lambda. And if you're not sure what Lambda is, I'm going to go into a bit more of a detailed discussion about Lambda itself. But the idea is that folks have an existing application built with Express or Flask or a PHP project, and they just want to get some of those benefits of running it serverlessly. So you can take a lot of these Express Flask, even some PHP applications, and just take them into Lambda and execute them there and have them running there instead of on an EC2 instance or containers. So that's the sort of first level of serverless that a lot of folks exploit and use. And from that point on, we start seeing folks building what we call mono lambdas, which is essentially a single HTTP endpoint pointing to a single Lambda function. And internally, the code itself is going to decide, oh, this is the path of this HTTP request, for example, and we're going to route that to a specific function, within our code here. So the code itself is managing the routing of requests and so on. And you have this one big fat Lambda function sitting there kind of doing everything. And then we start getting into what we're seeing as a sort of best practice coming out in the community is the idea of building a micro/macro services style architecture backend for an application. And I put macro because microservices was all the rage a few years back. Now it's not so great anymore, but macroservices is coming up as a great new way of building microservices that are a little bit fatter. We find this is the pattern now. People are building backend architectures sort of macro services style. And that leans into another architectural paradigm called Jamstack. And if you've heard of Jamstack, you'll know exactly what I'm talking about. I'm going to go into a bit more detail about Jamstack as well. But the basics is that you have a static front end with HTML, CSS, and JavaScript. And your JavaScript makes API calls to a backend for all the dynamic content of your site. So it's not an SPA necessarily, but it is a sort of old but new way of building applications now. So the reason I'm going to talk about the Jamstack in a bit more detail is that's kind of where my demo's focus is going to be assuming to a degree. So I'm going to be assuming a static front end calling a RESTful backend, for example. And Jamstack is, we call it static, but it's not actually static. It's kind of static but dynamic. And what I mean by that is that you've got your HTML, CSS, and JavaScript, which is all static files. But because you have JavaScript calling APIs and essentially hydrating containers in your DOM, it is a dynamic page for all intents and purposes. What's great about this, though, is that you can do things like take all of these static files and host them in very cheap and fast places like S3, for example, with CloudFront in front, if you're familiar with AWS. If not, Netlify is another great place to host these kind of static files. And like I said, JavaScript communicates with an API backend to make everything dynamic. And that API backend is then built as a collection of the macro services I was talking about before. So, forgive me. The other side of all of this is that the serverless part comes in usually with the backend side of things. So serverless has ways to help you manage deploying and running your front end, but that's usually a relatively simple task. You just need a way to build your front end, whether that's via React, Vue, or whatever framework you're using, and a way to push those static files into some kind of container that can then host them. The backend services, though, that you use to provide all that dynamicism to that front end is usually done using the serverless framework. And managed services are all the services in your cloud vendor that are provided as infrastructure as a service. So what I mean by this is it's not necessarily the EC2 instances and so on, but the more managed services like an S3, like Lambda and DynamoDB and so on. And for all intents and purposes today, we'll be using AWS. And generally, you'll find AWS is the most common cloud provider used for serverless these days, mostly because they have the widest array of managed services available to use when you're building your serverless application. It's totally doable to do things in Azure, for example, and GCP to some degree as well. But AWS have really, gone full out in trying to make sure that they are the serverless providers of choice, and it shows. So the idea as well with managed services is that you want to end up replacing a lot of the infrastructure you would normally have up and running to run your application with these managed services instead, so that you have less things to worry about. And what this means is it's not just about replacing that infrastructure, but it ends up replacing a fair chunk of code you would normally write too. And anybody who's built applications for a long time, you probably know that a lot of the time it's the code that is the weakest part of an application. Code is where bugs get introduced and where issues can happen. But you do need code to some degree, because that's where all your business logic lies as well. But if you can reduce the amount of code that you need to write and maintain, that's often a very good thing when building an application. And managed services end up providing a lot of the services that can take a lot of the headache away of running your application. And I'm going to go into more detail a bit about that as well. And these managed services are, in our case as well, and in code a lot of the time, are used via the SDKs provided by the cloud vendor, the AWS SDK, for example. And for the serverless framework, often use of these managed services is just built into your use of the serverless framework by default as well. So I'm just going to go through a couple of these managed services that we're going to be using in the demo today, just so everyone's sort of familiar with what I'm talking about. And API Gateway is the first one I'm going to bring up because, you know, in my past, when I'm building an MVC application, if I want to host this anywhere, ultimately I'm going to need a server, a VM. It's going to run Linux. It's going to have maybe Apache or Nginx or some kind of web server running on it. It has to expose endpoints. If I really want to take it seriously, I then have to actually create a load balancer in front of it that's going to maintain 2 to 3 instances running permanently all the time, billing by the hour, just to make sure that I can handle the request that comes in. And if traffic spikes, that's going to spin up additional EC2 instances. Very cool technology, but it has some downsides. And what API Gateway is, it's a managed service that provides me endpoints to make REST requests to, which ultimately replaces all of that Apache Nginx stuff that I might have had to have running in the past. And why this is great is that I now no longer have machines to worry about. I don't have to worry about that sort of load balancing stuff, because API Gateway essentially makes a certain number of requests per second available to you by default. So you don't have to worry about all that load balance stuff happening. You don't have to worry about the EC2 containers spinning up instances, spinning them down, how you manage load, waiting for 2 to 5 minutes for additional EC2 instances to manage your load for you. API Gateway just has 10,000 requests per second available to you, and can even have burst capacity beyond that. And if you really, really need more traffic, you can also just contact AWS, and they will just increase your default limits on request. What API Gateway provides you is not just an API endpoint either. It provides a bunch of features that you would normally have to have within the framework that you're building or within the code that you're writing. Things like request body validation. So what's cool about that is I don't need to validate my data coming in for my post request, for example, in my code. I will be using a JSON schema syntax to define what my post bodies look like. An API Gateway will accept or decline those based on the schema that I generate. Swagger support is included, API keys, and there's a ton more features. I can't go through all of them. This isn't an API Gateway talk, but API Gateway provides a lot of these features that you don't need to worry about or build. There's also things like authorizer integrations. So if you need to authenticate folks and then validate their requests based on their permissions, API Gateway has a way for you to do that through existing services like Cognito or Auth0, or even as a custom Lambda. And what makes API Gateway vastly different from running your own service is that it bills per request. There's no hourly rates, there's no minimum fees, there's no amount you have to pay per month to have API Gateway enabled. You only pay for the actual traffic generated. And because they have this really generous free tier, if you're testing things out with API Gateway, you'll probably never get a bill from them unless you're a really crazy busy developer, because the bills are only generated based on traffic. If you have no traffic, you are incurring no cost. All right, so that covers kind of our serverless, our web server portion of what makes up our application. The next step of that, the next tier of that, is our data store. Where do we store data that comes in from our application? And while relational databases is kind of the norm for most applications in the web, in serverless, the relational databases have a serious downside to them. And even if you're using a service like RDS, which makes it a lot easier, you're still bound by a machine, a VM with a specific set of CPU and memory available to you. You're also incurring cost on an RDS database. It doesn't matter how small they are, you're still paying by the hour. And most organizations, if they're running any database at scale with RDS, have to have a really large instance sitting around permanently waiting to receive traffic, just on the off chance that suddenly they're going to hit their maximum peak load. So you have to keep this massive instance sitting around most of the time. Serverless Aurora kind of tries to answer that to some degree, but again, I'm not going to go into super detail about RDS here. That could be a talk all by itself. But why DynamoDB is interesting is it's very similar to API Gateway in that it's a fully managed NoSQL solution that provides infinite scaling for your data store needs. And is a really great replacement for relational databases for data persistence. And I'm not going to sit here and pretend that DynamoDB is an easy thing to just jump into immediately and start using with zero learning. It is a bit of a beast to get to know and get familiar with. In fact, Connor was recommending a talk at some point about DynamoDB itself, because it is quite a beast. Thankfully now, these days, there's a lot of really great content out there if you're interested in DynamoDB and really want to get sunk in. And in my opinion, it is the ultimate in a serverless data store to use for a serverless application. One of the reasons for that is that it's super fast. This is probably the fastest data store I've ever seen in my life. They guarantee single-digit millisecond latencies on queries into the data store. This is sort of part of their SLA. This is just part of standard practice for DynamoDB. There's also, just like API Gateway, there's no minimum fee. You're not incurring an hourly cost to run a DynamoDB table. You're only getting billed based on the amount of data that's stored and the reads and writes that you perform on your table. So again, if it's 2 a.m. in the morning and you have no traffic on your site, you're not paying for this database instance sitting around doing nothing. And just to give you an indication of the ultimate scale that you can achieve with DynamoDB, they quote a capacity available to everybody by default of 40,000 RCUs and 40,000 WCUs. And this RCU, WCU thing is AWS's way of calculating capacity. There's a little bit of a formula that's involved in what that actually means, but for all intents and purposes, you can consider one RCU to be one read, one WCU to be one write. So really what they're saying is that you could go up to 40,000 reads and writes per second. Pretty massive. And one of the other cool things is that DynamoDB has an unlimited table size and an unlimited number of items that you can add into the table. And this also means that the query times are not affected by the quantity of data you have. Unlike relational databases, a lot of the time where you're building joins constantly, and the quantity of data sitting in your tables is going to affect the query speed of your application. This is not the case with DynamoDB. All queries will always have the same query speed. And again, this is DynamoDB has a very generous free tier. So if you're just busy developing on your local machine, there's ways to make sure that you're not going over a free tier and incurring a cost of DynamoDB just by trying it out. So it's pretty cool in that way. And even if you are trying it out as a single developer, I don't think I've had a DynamoDB bill with really extensive usage, incurring more than I think $1 a month in cost anyway. Right, so we've looked at the networking side with API Gateway. We've looked at the data store side with DynamoDB, but we also need somewhere to run code, to actually run compute. And Lambda is normally seen as the poster child of serverless. A lot of folks, when they think of serverless, Lambda is what serverless is. And from what I've probably shown already, you can really see that Lambda does not equal serverless. Lambda is very important, and it's an important part of building a serverless application. But it's not the be-all and end-all. And the reason I say this is that a lot of the previous services that you'd normally use to build a serverless application have been around for quite a long time. Services like S3, SNS, SQS, even DynamoDB have been around long before Lambda. Lambda basically became generally available only back in 2015, and that might seem like a long time ago now. But it's actually not so long ago, considering that a lot of these services were released 2008, 2010, and 2012. A lot of them have been around for a long time. And the missing piece really for compute, for building a proper serverless application, was Lambda, to really fully say you can build a serverless application. So some of the performance characteristics of a Lambda function, and if you're not sure how you execute Lambda and stuff, we are going to look at that in the demo, so don't worry so much. But just some performance characteristics to understand what Lambda is capable of. If you are running, you can run 1,000 Lambda functions simultaneously in parallel. which is an enormous amount of parallelization that you get out of something. Lambda is really awesome at running simultaneous executions at the same time. And if you worry that this means you only can have 1,000 requests to your application at the same time, that's not what this means. What does in simultaneous executions of Lambda is quite a lot of execution bandwidth that you get. And I've worked with on sites that we deal with 10,000 simultaneous users on a site, and we never go over 5 or 6 simultaneous Lambdas running concurrently. So it's pretty awesome that way. This limit, though, if you feel like you are going to reach it, can be increased. So you can just say to AWS, I think I'm going to need more than 1,000 simultaneous Lambda functions, and they'll bump this up for you, often just right up to 10,000 requests. And you also, just like the other services, you don't pay a minimum fee. There's no monthly charges. You pay per 100 milliseconds of actual execution time. And if anybody knows anything about Lambda, you'll know about cold starts and hot starts, and Lambda functions that have already executed once will now sit around warm, waiting for the next execution. This 100 millisecond bill that you get is not for a warm Lambda function waiting for its next payload to execute. This is only execution time when it's actually running your code, or you're paying for execution time. And there's various performance levels as well. So Lambda has some knobs and dials for you to tweak how much performance you want to provide versus how much cost. The more performance you provide to a Lambda function, the higher the cost per 100 milliseconds. So it's a nice way for you to balance between I need speed versus I need to reduce cost. And again, Lambda has, a very generous free tier. And all these free tiers I've mentioned so far are not the 12-month free tier you get with AWS. Those are permanent free tiers that exist in perpetuity as far as anybody can think forward. So it's pretty generous in that way. You can build your serverless application, test it out in development, and never pay a cent until you actually start driving some serious traffic. So why is all of this managed stuff, the serverless stuff, such a good thing for us? How can this really help us? So first of all, this seems quite obvious, but there's no servers to worry about. You don't have to worry about the underlying hardware of your virtual machine and the CPU, memory, and disk. There's no OS or application updates that you need to constantly worry about and update. Heartbleed is not something that's going to be a concern for you. There's the underlying network configurations and container and Kubernetes configurations, which, in my opinion, containers and Kubernetes have just made things far more complicated than before. There's none of that configuration worry that you need to worry about. You don't look at any of that underlying architecture, nothing. You just worry about your code and the managed services that you use. Load is also automatically managed for you. You don't need to set up load balancers and scaling schemes and any of that kind of stuff. It's all just done for you. And you just need to understand what the limits of the services are that you use and know when to contact AWS or your other cloud provider to say, could you increase my limits so that I can meet this demand? That's really all you ever need to worry about. One of the things to point out is that just as you can scale up and meet demand, scale down is something that a lot of folks don't often think about. And traditionally, if you're running EC2 instances, you're going to spend time. Spinning up EC2 instances takes time. It takes 2 to 5 minutes to spin up a new instance. Sometimes you have to spin up 4 or 5 or 6, 10 or 20 of them to meet your demand. But then you also need to scale those back down. And normally you don't scale them down too quickly because you don't want to start scaling down and have to scale back up again for events. So this ends up incurring a lot of cost usually for folks running a busy application. But with serverless, your scale down is instant and automatic. Just like you can immediately provide 10,000 reads per second in API gateway, if reads stop, that's your cost is saved. You're not incurring that additional cost of stuff still being scaled up, trying to slowly scale down again. And the other point to mention is that you can scale to 0. So you can actually get down to cost of nothing, which is pretty cool as well. If it's 2 a.m. in the morning and your only traffic comes from people living in your time zone, well, you're not going to incur any cost from EC2 instances, relational databases, and all these other things sitting around billing you by the hour. And you only pay for what you actually use, and often nothing. I've built solutions for folks who are still sitting with a AWS bill of 53 US cents a month simply because that's what the Route 53 DNS traffic is that they're getting. They're not paying for any of the actual execution time, API gateway, DynamoDB, and so on, because they haven't breached any of those free tiers yet. A pretty compelling way to get started. But there's obviously a downside if you're thinking about just using all of these little, compiling these services together to build your application. First of all, how do you set all this up? Are you going to go to API Gateway in your AWS console and create an API Gateway endpoint there, upload your Lambda function through the Lambda interface and so on? That doesn't sound like a great way to build an application. How do you share this with the team? So if you have a group of developers, you all want to work together in building your application. How do you share this amongst your team members? You can combining infrastructure with code in this way. So you're setting up infrastructure in a console and then writing Lambda functions and then trying to maintain versioning of that sounds like a tricky thing to do. This is ultimately where the serverless framework comes in, and there are other frameworks that can help you build serverless applications. The serverless framework happens to just be the most popular of the serverless frameworks out there. And just to go through a bit of a background on what the serverless framework is, first of all, it's an open source project. So if you go to GitHub, we have a GitHub with all the code for the serverless framework available. It was started back in 2015, right in the early days of Lambda, initially called Jaws by its creator, Austin Collins. He had to change the names for various reasons, but found serverless was available, so why not? And right now, like I said, it's a fully open source project with an MIT license. It's hosted on GitHub with over 30, well, I should update this. It's actually over 35,000 stars right now. So it's, like I said, it's quite a popular open source project. And we do have a full-time core team working on contributing and building out the open source framework, as well as a very wide range of contributors from the community that work on the framework as well. In fact, I think our most recent release was pretty much contributions by our community as a whole, providing new features and some bug fixes as well. We also have a very large community of plugins that extend the functionality of the framework. So if you do have some niche use case that isn't covered by the core framework, you can build a plugin that hooks into the entire deployment process of the serverless framework to add additional features that you might want. And yeah, you can just go to github.com/serverless to take a look at the project itself. And a bit more information about what the serverless framework is and what it does. You can think of it as an infrastructure as code type of tool, but far more focused on application development than just infrastructure deployment. And the idea is that all those managed services that I was talking about before that you can use to help build your serverless application, you can specify how they're deployed and what their configuration looks like through a configuration file that the serverless framework bootstraps for you and that you can build upon. There's a CLI tool that ultimately will take this configuration file that you build up, as well as the Lambda functions you write, and you can run commands with the CLI tool to deploy that into your AWS or other cloud vendor accounts. And it makes deploying all of this infrastructure that you want as portable as possible. So it's pretty great in that you can take this infrastructure, deploy it into your AWS account, take this project that's all sitting in code, pass it to another developer in your team, and he can do the same to his AWS account. And this means that you can now build together, you can collaborate, he can make edits to what you sent him, and you can obviously share this through your own Git repo, deploy into your own accounts, merge that together to deploy into a production account. So it gives you the ability to build an application as a team and deploy things together as a team, maintaining some kind of state and version of your application. It's also possible to configure cross-vendor, so it's not just limited to AWS, and you can actually support multiple vendors in the same project. Each vendor can have their own configuration file to define the infrastructure needed for that specific vendor. And just an indication, this is just some of the commands available in the CLI tool. We're going to take a look at a few of those today. And then this is just a very basic configuration file, and this is in fact enough to deploy something into AWS, so it doesn't necessarily need a massive amount of configuration. With that, I think we're going to go into a demo, and I'm going to try. The tricky thing with demos is to try to avoid the whole situation of let's draw a cat. Here's a circle. Now draw the rest of the cat. So I'm going to try and do something that looks a bit more than just that basic premise. So before I get started with a demo, does anybody have any questions at this point? And you can feel free, I think, to unmute yourself and actually talk if you like. Cool. I think I'll go on with the demo unless somebody pops up. Okay. All right. So first thing I'm going to start off with is that...
if I can ask you a question, sorry, I was trying to find the unmute button. For setting up, do you have to have your IAM policies and stuff set up specifically for any of this, or before you connect to your account?
That depends. If you need to, if your organization requires you to do that, you totally can. If not, then you don't. I know that sounds a little vague, but really you have the option of using defaults or using your own IAM policies that you might prefer. So the Serverless Framework itself automatically builds IAM policies when you deploy based on the infrastructure you've configured. And then you can also link to a specific CloudFormation role in your AWS account to use for deployment time. And I mean, there's a whole bunch of stuff around that. So if you do want more information, feel free to hit me up on my Twitter as well, and we can chat. My DMs are open as well. But in general, yeah, you can specify unique. You can use defaults. It's completely up to you.
Okay, thanks.
Okay. So one thing I'm going to start off talking about is there's multiple ways to configure how you want to deploy into your AWS account. I'm going to be using the serverless dashboard to help me with this. And the reason why I do this is that, in my opinion, it helps make development a little easier. And we're going to be using one of the new features called Studio to help us do that. So really what I do is I have a serverless account. And really, if you go to dashboard.serverless.com, you can create a free account there. There's no cost involved. There's a free tier available here as well. But what this lets me do, for example, is I can create a deployment profile and connect my AWS account to a deployment profile. So if I just click Connect to AWS, it's going to open up into my AWS account and start helping me create just a quick CloudFormation stack that creates the necessary permissions and roles for me to deploy through my serverless account. So I'm going to do I'm going to name this serverless project. I have a bunch of these, so I have to actually create a different name sometimes for them, just to avoid conflicts. But usually if you're starting for the first time, you don't even need to worry about that. You can just go ahead and create a stack. You see I've got a bunch of stacks created here already. And what this means is that when the stack finishes creating, it's automatically going to connect my serverless account to my AWS account to make my deployments a lot easier. Just waiting for the stack to finish creating. This takes a few seconds, and this should be done soon. There we go. You can see I'm now connected. So it's automatically filled in the role permissions that I need to connect to my AWS account. So now I can carry on. And what this means is my deployment profile default has now got a connection to my AWS account for me. And on my command line, what I'm going to need to do is I need to now connect my CLI to my serverless account. So I can just run a SLS login. I'm already logged in, so I'm not going to execute this now. But what this will do is open up my browser, let me authenticate into my serverless account, and now I have access credentials to my serverless account, not my AWS account on my local machine. And ultimately, in organizations, this is often a useful feature, so you don't have to dish out access credentials to a team of developers to an AWS account. That's often a security concern for a lot of organizations. If your team does have a serverless account in this way, you can manage that process of handing out credentials to AWS itself. So what I'm really going to do here is I need to go into my projects folder, and I'm just going to create a brand new serverless service. So just think of the idea of maybe I'm creating a CRM application and I now want to build sort of microservices style of architecture here. I'm not worried about the front-end side of things for now. You might do things differently. But thinking about a CRM, I may have a contact service and a lead service and a company service and so on. So I'm going to start with building a contact service for my application. So to do that, I'm just going to run this. So just first of all, installing the serverless framework. People are watching, I can't type. It's as easy as just installing through NPM. Serverless Framework is available in NPM. If you do want to use other runtimes, there are binaries available as well, if you prefer that. I've already installed it, obviously, so I'm not going to do that. I am going to use the Serverless Framework to help bootstrap my first service. So just running the serverless command will run a bootstrap process that's going to ask me a bunch of questions, including the fact that it hasn't detected a serverless project. So it's asking me if I want to create one. So I'm just going to say yes. I'm going to use Node for the runtime available here. This bootstrap, the serverless command that I've just run, only supports these two runtimes right now. But if you use the serverless create command, you can then access all the other dozens of templates and runtimes on different environments that we support. I'm just using this because it makes things a bit quicker. So I'm going to call this my contact service. It's now created the folder for me, but now it's also going to try to connect me to my serverless account to set this up in my new service. So I'm going to say yes to enabling this. It's now going to ask me which organization. So one of the concepts of the dashboard is that you have an organization that contains apps, and each app contains the services for your application. So this service is going to be deployed to an organization and an application within that organization. And I've already ahead of time created an organization called Serverless CRM for this demo, so I'm going to pick that one. And it's now going to ask me to pick the application inside that organization to use. And I already have one available. Just waiting for it to come back. There's a Serverless CRM application I've already created, or I could create a new one. So I'm just going to go ahead and create that. And now I've got that set up. So I'm just going to go into that and then open up my editor inside that folder. Oh, and it's on the other screen, so I'll bring this over. What we have here is essentially a bootstrapped version of my service that is, even right now, I could deploy this into AWS if I wanted to, but now I can start adding what I need for my application. So we've talked about those three pillars, the HTTP, the data store, and the compute. I'm going to start adding this into my application. So the first thing to go through is you can see there is a serverless.yaml file. So this is the just going through sort of these files. The real file that matters is the serverless.yaml file. And this is sort of the core part of the framework that helps you configure your application for the cloud. And here you can see I've got a name for my service that I entered into the command line called contact service. Here is my app and org that I connected it to in my serverless account. And here, there's some basic information. My runtime is Node 12. I'm already also pointed at a Lambda function here called handler.hello. And by default, you get this handler function gets created, and this is a working Lambda function you can see here. We're going to build our own in a minute. I'm not going to use the default handler function, so I'm actually just going to delete this quickly. Just delete the right file. Delete you. And I don't need to reference this handler function here, so I'm going to remove that. And then, yeah, there's a lot of commented out sections here to help you figure out how to build the things you want. What we're going to do is we're going to build our first function. And usually what I do when I'm building a sort of CRUD-style RESTful APIs, I try to build the create function first, because that's often useful for testing. Because if you build your get first, you don't have actually anything to actually get out of a database. So let's go ahead and build our first application. And I'm going to start by creating a bit of a folder structure here. So there's no defined folder structure. You can create whatever you like. I'm going to add a new folder and call this src. And within that, I'm going to create a new folder called functions, because maybe I have another one called tests, or another one called schema, or whatever it might be. And within this, I'm going to create a new file. And this is going to be my... oh, I told you I can't type when people are watching. Alrighty. Create contact.js. And luckily for all of us, here's one I prepared earlier, so I'm not going to go typing an entire Lambda function out. Thank goodness. So yeah, I've just copied out some code here. And I'm just going to go through what the basic structure of a Lambda function looks like, so everybody make the font a bit larger. Okay. I think everybody can see the code now. Am I correct?
Yeah.
So this is really just a folder structure here. This isn't really that big a deal. This is, I think, where the meat things. Or do you want this a bit larger too? I think I actually have presentation mode. That should be a bit bigger. Okay. So the idea here is that a Lambda function essentially consists of a function, funnily enough. So here you can see, for example, I have a function called create contact. And you have code that can sit outside a Lambda function, like this require for the AWS SDK. And you can do a number of things outside of a Lambda function as well. So part of the process with Lambda is that when you have a request coming in and it causes a Lambda function to execute, that Lambda function needs to be spun up and created in the background. And this is called a cold start usually. And a cold start will initialize all of this content that's sitting outside of your Lambda function. And this will only happen once during that cold start process. But every further invocation that comes from that point onwards uses a warmed Lambda, which means that it doesn't need to run this code outside your Lambda function again. It only executes the actual code in your Lambda function. If you play around with Lambda, you'll see this in action. It's a very cool feature to do things like only create database connections once or something like that if you are actually talking to a relational database. The deal with the Lambda function is that we have a function that gets passed to objects. The main one to worry about usually is the event object. So if you have multiple event types calling a Lambda function, the event object here will differ depending on that. In our case, it's going to be API gateway. So you can actually think of Lambda as being event-driven, which is pretty cool. So we'll take a look in a second, but I can have many different types of events calling a Lambda function. And the context object that's passed here is usually to provide you literally context to the environment that your Lambda function is executing in, because there is still a virtual machine underneath all of this that's executing your code. And often you might want some information about that virtual machine and so on from your context object, just to help things along. To go through the code, yeah, it's actually very, very simple. There's only something like 20 lines of code or 30 lines of code or something like that. First of all, I'm just doing a console log here to get things sort of started. I'm then reading the body parameter out of my event object. So because this comes from API Gateway produces something like an HTTP request style object with body content. This is a post request. There's going to be body content. And I parse this so that I get all the elements out. I then create the object I need for DynamoDB to put items into my DynamoDB table that we'll create in a second. And this literally is just going to create an item with 3 fields: email, first name, last name. Then use a try-catch block to call my DynamoDB table and put that item in it, and then return success if it passed. If there's an error, it's going to return an error, and that's pretty much my Lambda function. Very simple, very quick and easy, nothing super complicated there. So now I have to drop out of presentation mode briefly because we need to now set things up in our serverless.yaml file here. And this is where, I'm just going to save this file before I forget. And this is where I now need to, I've got some code sitting in a Lambda function, but I need somewhere to know how that is configured, how that's going to be deployed, how I'm going to put that into my AWS account. So coming to my serverless.yaml file here, I'm going to add a function here called create contact. And again, I think I'm going to end up reusing something I've prepared earlier. Let me just find the function definition, just so I don't make any mistakes. And then we'll go through what that looks like. Alrighty. So you can see here, basically all I'm telling the serverless framework is that I have a handler, a serverless function sitting in source functions. The file name is create contact and the function name is create contact. And I want this to be triggered by an event. So I can add events to my Lambda function. And in this case, we're using API Gateway. So the serverless framework says just mark it as an HTTP event. And this works cross-vendor as well, which is pretty handy. So the API Gateway equivalent in Azure and GCP would also be an HTTP event. Although I think GCP's only recently put their own API Gateway equivalent into beta, but I think you understand what I mean. And very similar to doing pathing in most applications, you set up a path such as v1 contact. In this case, that's all we need for our post endpoint. The method is post, and we can set up calls to be true so that options requests are also managed by the API Gateway. And literally, this is all we need in order to create our function inside AWS. But if you remember, we had code, and yes, I can switch. We have code here talking to a DynamoDB table. So we also need to create that in some way. So the idea, again, about services is that you're not creating the service just with code like you would traditionally, and then you go off and create a database. And while you might have an ORM and a schema traditionally, you don't have the database creation event usually involved in setting up your application. But because we have portable services that we want to maintain all the infrastructure within them, we want to define our DynamoDB table as a part of the service as a whole. So to do that, I'm going to go to my serverless.yaml file again, and I'm going to actually specify the information I need to create my DynamoDB table. So I'm going to scroll down to a commented out section here labeled resources, and this is where I can start adding in CloudFormation resources essentially. And what CloudFormation gives me is the ability to now spin up additional resources in my AWS account following AWS's own preferred infrastructure as code mechanism. And if that means that if there's any resource that I want as a part of my application that can be defined through CloudFormation, I can add it into a serverless.yaml file, which is pretty neat. And that's it. I've now added some basic configuration here to create a DynamoDB table. So I've got now a data store automatically created when I deploy now. And the structure is very simple. This is saying I want to create a DynamoDB table, and this is CloudFormation from AWS. So this is not directly related to the serverless framework, and there's a ton of documentation about creating this kind of syntax. So don't worry too much about that if you need to create your own things. But I can specify a table name, which I've done here, and I've got, I need to define a key to search across in my DynamoDB table, and I can also set my billing mode, and I'm just keeping it pay per request to keep it simple, but there's many ways that you can manage how your requests are optimized or billed and so on. And that's really it. I just need that to create a DynamoDB table. But also, last thing, as you can see in my code, a couple more things. In my code, I have an environment variable. If you're familiar with Node, this is accessing an environment variable in the environment that the Lambda function is executing in. So I also need to tell the serverless framework to add an environment variable for my Lambda function that accesses this table name. So if I go to another commented out section here, labeled environment, I can now set up an environment variable for this Dynamo context table. I'm going to copy that here. And if I go to the end here, I just want to copy this name. So we're back at the resources section here. I'm going to copy the name of my DynamoDB table. Go back to the environment section quickly. And now I have my DynamoDB table available for me to view or access in my Lambda function. All right, so last thing I need to do is, and this is also actually a really cool automatic feature you get out of using serverless, is that my Lambda function here that I've defined wants to access DynamoDB, but by default, Lambda functions do not have access to DynamoDB. And this is a great security feature where you need to add permissions explicitly to resources you create for your service. So, for example, what I'm going to do is let me just add this in so it makes it a bit clearer what I'm doing. Again, I'm just looking at what I prepared before. So let me grab this little definition. And I'll find there's a commented out section here as well about IAM role statements. So I'm just going to create my own one up here. Go back, just pasted it. And what this does is essentially say to the serverless framework, please create an IAM role for my Lambda functions that allow access to DynamoDB put, so it allows my code to put stuff into DynamoDB, but also to query, because I may need to query stuff out of the database, out of the table. And then I can actually tell it exactly which resource in AWS to access. And a part of this is, well, you can see I've defined a resource here, and I'm defining the exact resource to use using that table name. And I have some syntax here to specify the region and account ID. Now, this is where we want to maintain portability. I don't want to hard code the region and account ID because I might want this to deploy across multiple regions and accounts. So I'm going to use this syntax here, which is actually making use of a plugin. I just need to drop out of here so I can access my terminal for a second. One of the, I don't know if I can, no. Terminal does not like that. All right. So there's a plugin that I often use with serverless applications to help me make specifying these kind of variables much easier. And I mentioned that the serverless framework has a plugin system which helps with all of these kinds of things, which is pretty cool. So using the CLI, I can now install this plugin to help me manage these. So the serverless, to make sure I typed the name correctly, the serverless pseudo parameters plugin will help me with these kind of pseudo parameters, as they're called. And just using that command, it's automatically going to install this plugin for me. And it's successfully installed. So that's great. So now this syntax of hash region, hash account ID will be replaced by the actual region and account ID based on where I deploy into. And we're going to see that in a second as well. Right, so I think I have everything set up here. I'm connecting to the correct serverless account. I give my DynamoDB, my Lambda functions with the right permissions. I have an environment variable set up as I need. My functions are referenced correctly. I have a DynamoDB table created that I need. And this should now all work. So I'm going to now use a new command that's come up recently. This is a new feature of the serverless framework. It's something called Studio. And it's a way, traditionally, if you've used serverless in the past and tried to build things locally, it's usually a local development is a bit of a pain. I'm just going to get this started. It can take a minute or two. Because as you'll see, to deploy into AWS requires a deployment process involving CloudFormation. And traditionally, CloudFormation is actually quite slow in AWS. So these deployments can take a minute or two, depending on the complexity of the configuration you have, which makes developing serverless applications a little slow with that whole development iteration loop. Because if you make a change to your Lambda function, if I have my Lambda function here, for example, and I make a small change, and then I deploy into my AWS account, and it takes a minute or two, and I realize that there's a semicolon missing, that's going to be annoying. I have to make that change. I have to now deploy again. That takes another minute or two. Then I realize I've misnamed a variable. So I have to change the variable name. I need to redeploy, and then I find something else that's something else that I need to correct. So the whole idea with building Serverless Studio is this is going to give me a way. I just want to find that's my wife. I just want to find, okay, so I'm in my org here, and if I go to Studio at the top, because I use the Studio command in my CLI, this will now resolve into a nice little view here for me to start testing my application. And once this finishes deploying, we're going to see that Studio change. So the idea here is that I want, similar to how React or Vue has your local development environment, you can spin up a local dev, which creates a browser window. You make a change to a file that automatically refreshes your pages for you so that you can see that content. Studio works in a very similar way in that I'm going to be able to edit my Lambda function, have it automatically update that Lambda function within seconds so that I can immediately test in the cloud. And the reason for this is that you might think, why don't you just run your code locally? And there are ways to kind of do that to some degree. The problem with them is that ultimately, because you're building a serverless application, you are dependent on cloud services to do that, which just means that testing locally isn't quite as accurate as testing in the cloud directly. There are multiple techniques. I've written a couple of blog posts on how to test locally to some degree. But really, you ultimately have to test in the cloud anyway, because the resources in the cloud will act differently to any way that you might implement them locally on your own local machine. So this is why Studio is so great. You're actually deploying into the cloud, and this one-time deployment is now going to start watching for changes. You can see it's already watching for changes here. And if I have no bugs in my code, which there probably is, so I'm not going to hold my breath, I can now, in a Postman-style interface. This is pretty cool. I've already just glossed over all of this because this is... I've been looking at this for the last couple of days. This is a very new service, so it's in beta. As you can see, we're probably going to see some bugs today, and if you try it yourself, you might as well. But the team is busy working very hard on making this better, improving it, fixing all the bugs, and getting it out to full release. But it still works incredibly well right now to do what we need to do. So, for example, I'm going to create a quick object here. Oh, my goodness, again, contact. Forgive me, it is almost 6 a.m. I've been up since 4, so yeah, fun times. I now have a first name. I'm just going to call this a first name, and then I have a last name. I don't know if I have. I may actually have it done by DBT created from before, so I'm just going to randomly create some characters here to make it a unique entry, and this should work? Question mark. So if I just send this request, this is now testing my API endpoint. And there was an error. So access denied exception. Looks like my IAM roles weren't correct. So I need to just fix that. Let's go take a look at my code and see what I might have done wrong. So it looks like my IAM permissions weren't set up correctly. Go back to my serverless.yaml file. Oh, that's because I didn't save my YAML file. So when I save my YAML file, this was changed externally. So compare, oh goodness. Yeah, so my IAM role statements weren't saved, my bad. I seem to do that all the time. I'm going to close my terminal for now quickly and overwrite file contents. And really what all it's done is that it's removed my plugin, so I just need to add my plugin back. That should do it. And now I'm going to, it's just checking for function change because I changed my serverless.yaml file. So the only time that it's going to do a full redeploy, or will require a full redeploy of the, did Studio update the pseudo file? No, it shouldn't have. So I'll talk about that in a sec now. I'm just going to, okay, so I need to actually cancel out. So this is one of the bugs that I picked up yesterday with Studio, is that when you update your serverless.yaml file and save, it should be doing a redeploy. It's not at the moment. That's something that I'm going to tell the team about. So I'm just going to manually tell Studio to restart and redeploy my service here, restart Studio. But as you can see, I didn't have my IAM roles saved. These permissions are saved, so immediately my code errored out, and obviously I'm restarting Studio, so we can't see the error message right now. But ultimately what happened was that Studio ran the code, executed my Lambda function, and it came back with an error message saying that I didn't have permissions. And that's just a demonstration of how, by default, Lambda doesn't have permissions to anything until you tell it explicitly. I got to see a question from Dom asking if Studio updated the pseudo file. So what pseudo is it's just a parameter that you can, so if I go back to the code, you can access details. So when I'm deploying here, let me just backtrack a little bit. When I'm running a deploy command here, this is essentially deploying my application into the cloud. And what this does is apply a region by default, and the default region is US East 1, and you can change that. You can see here, I've got a region specified as US East 1. It's commented out, that's the default. You can add many other regions there, pretty much all the AWS regions, I believe. In fact, there was a new one for Cape Town created 2 weeks ago, which is great news. But by default, we use US East 1 as a region, and also you can apply a stage, which is the parameter that I've passed here. And I've named it Gareth just to differentiate it from any other stage. And what the stage is, it's a way to namespace or create a separate environment for my different deployments. So if you're building an application, you may have a staging environment, a development environment, and your production environment. And by using a stage parameter, you can differentiate between them. Sorry, just had to push the cough mute button. Yeah, so I'm using a stage here to help differentiate that. And this is one of the great features of the serverless framework, is that you can maintain these multiple environments. And there's also the deployment profiles that we looked at before in the my serverless account. I can create different deployment profiles pointing at different AWS accounts for different stages. So that's a different topic. And if you're interested in that, please chat to me. And I've created an error. I know what this error is. I'm trying to remember what causes it now. Malform policy document. I think I know what the problem is. Oh, I've probably broken my plugin. So let me just do this again. I'm going to close that. Make sure I install my pseudo parameters plugin properly this time. Okay, if I go to the end, you can see, oh, that's why I named a plugin, not plugins. So there was my error. Okay, so let's start that again. Okay, and you can immediately see this is why Studio is so awesome, because if I had to redeploy every single time I made a code edit, and it takes us a couple of minutes, it can slow down development a bunch. One of the things I can do is, though, looking at my dashboard account here, I want to take a look, because if I wanted to see more information while we're waiting for that deployment to just finish quickly, I'm going to go into my apps section here that I've got. And I can, once this loads, I should have loaded this before. Based out of Cape Town, latencies can be a little annoying. But what I can do is I can go take a look at more information about my invocation that I ran on my new function. And this is useful because I get a lot of useful information out of this. So here's my serverless CRM application that I've deployed to. You can see my deployment failed there. And here's the stage Gareth that I deployed to. And I can go to my overview here and see that I have an invocation, an attempt to run my function happened, and I have an error. So I'm going to go take a look at my API error. And immediately I can see here is the actual detail of that error and get more information about it, including the CloudWatch logs. So by default, when you log out information, as we've done in our code here, code, if I look at my Lambda function, I've got console logs here. So in the runtime, this logging output automatically goes to CloudWatch, which is a service inside AWS, and your serverless account can pick up those CloudWatch logs to help make them available to you, as you can see. Yeah, so we have our CloudWatch logs saying the exact same thing we saw in Studio was that I had an error with my access denied to my DynamoDB table. All right, so I think that the deployment finished there. Yep, it's now watching for changes. So let's go back to Studio quickly and test that out again. And I should have saved that, and I didn't do that. So let me just do a test event here. I'm going to add my body back, which is going to be email is email@email.com. I'm going to give it a first name, and a last name, just a last name. Doesn't really matter what it is. I'm going to do that. I'm going to save my little event here, and let's test it again. And you should work now. Yay! We can see there's my invocation. There's now logged out that started. Let me go take a look at more detail. I can see this is the event. So I mentioned the concept of the events. This is API Gateway's event object. So my Lambda function received this entire object based on the HTTP request that Studio created for me. It's a post request. This is all the headers that are passed. It has another thing called multi-value headers. It has the request context. It has the body. Here's the body that I put in. The response code that came back from my Lambda function was a 20201, so my item was created. And there's whatever details, there might be additional details to that as well. But what's cool is I can also take a look here, and to my function, I can start looking at the metrics that came from the actual execution, how much memory it used, timing. It's a very, very cool interface to see all of this information by default. So to quickly wrap up the discussion, because we've been on here a long time, I want to add one more function very quickly. I'm going to create a new item called, what did I call it? Get contact item.js. I want to retrieve an item from my DynamoDB table. So again, I'm copying some code I prepared earlier. Very simple. I'm going to run this very quickly. Same concept as before. I have a function called getContactItem that receives an event object and a context object. I have a query that I create for DynamoDB that uses the email from the event. So this receives a path parameter, and you'll see what I mean by this. So we can pass the email address as a part of the URL that's used to call the endpoint. That's used in my query here. And this is just what you write in DynamoDB to run a query against your table. I then run my query on DynamoDB and return 200 with the data I retrieved, or a 500 if there was an error.
Hey, Gareth, I think you got muted. One second.
Oops, sorry, I muted for cough. Okay, so all I'm doing is I'm grabbing the function definition for my get contact item. So I've got the function in code sitting there, get contact item. I'm creating this handler now in my serverless.yaml file, and I now need Studio to update. I'm not going to bore you guys with sitting around waiting for that update, but ultimately I could then use Studio to retrieve the data out of my database. There we go. And that will now allow me to continue to build this. So in the hour that less than an hour that I've been making a demo, ultimately what has happened is that I have been able to, and we obviously haven't typed out the code, but as you can see, it's literally 20 to 30 lines of code and nothing monstrously complex. But what I've been able to accomplish is I've created 2 endpoints that give me a production-ready CRUD API that I'm testing in a semi-local environment with Studio. I can now go and deploy this using --stage prod, as I mentioned before, into a production environment and start serving actual traffic with this, because it instantly has availability. It's instantly got 10,000 requests available per second. It can start handling API calls from an API from a front end. I can go and add my update endpoints. I can have an update contact item, a delete contact item function created, and very rapidly get myself an API up and running. Last thing to mention is there isn't only HTTP events. In the commented out section here and in the documentation for serverless, there's a ton of events that you can use as well. So it's not just about hooking up API events, which make this really awesome. If you have a use case like processing images, you can do things like link a Lambda function to an S3 bucket. So when an item is added into an S3 bucket, it'll automatically trigger a Lambda function that can then do some work on an image file or whatever your use case might be. A lot of folks end up using serverless in a proof of concept way to help run their cron jobs. So you can use the schedule event to do that instead. In the past, I've had to have an EC2 instance around just for doing cron jobs, which is a little annoying because those don't happen all the time, but you get billed by the hour. So instead, I can use this schedule event to trigger my cron jobs instead. All the way down to doing things like using DynamoDB streams. So if you've ever tried to write code inside your database itself that gets triggered based on records being updated, that can be annoying as hell because those are usually very database vendor specific. But DynamoDB gives you a concept called a stream where you can send updates to your database table to a Lambda function to do additional processing on if you need to. And as we wait for the studio update here to finish, I can see I've got a get contact item here. I'm going to hopefully be able to grab that email address that I had before. Let's just grab the body. I can't remember what it was. Let's just grab that email address. Let's test this out. And if I haven't got any errors, which I may have, but we'll see, I can now test that request and see what happens. Yay, it works. I've now retrieved my data from my database. So the studio is telling me there's my data that I retrieved. And again, I can look at all the information I need, response, and so on. So yeah, there we go. I've now gotten a way for me to build everything I need. I think that's the end of the demo. And I think we have some time for questions. Correct me if I'm wrong, Connor. I've gone through a lot. The massive knowledge dump at the moment, but there's usually so much to go through when it comes to serverless stuff. It's tricky.
Yeah. Awesome. One question off the top of my head is when you've seen different either customers or developers developing serverless apps, what are some of the most popular stack, I guess, for people building web applications? Is there do you need to do queuing or authentication, or if you were building this CRM more fully, what would be some other services that you'd want to connect with Serverless Framework?
Okay. I'm unmuted. Okay, I'm just making sure again. So I'm actually going to find a project that I built in the past. I started building for a friend a few years back before I joined the serverless team. But I think it's a nice demonstration of what a sort of production style application might look like. And what you're seeing here, let me just close all of these for now. So this is I know this is a bit small for folks. I don't know how to increase the size of this. I'm sorry, the files here. Let me actually just do this. This might look a bit easier to see. This is my file system. So here you can see here's a folder called Going Out. This is the app. It's called Going Out. It consists of multiple services, including a front end. This front end is literally vanilla JavaScript, HTML, CSS. There's nothing fancy about it. There's no funny or fancy JavaScript framework, anything doing there. It's just regular HTML, CSS, and JavaScript. And sorry, these services all work together to provide the application with all the features that it needs. So what you can see, the short version of what this app is that it's a reward system for people visiting restaurants. So you can get discounts on visits to restaurants by booking ahead of time with the service, and you get discounts. I mean, it's a relatively simple process, but you pay monthly for the rewards program. So the idea here is that you have multiple services managing all of this interaction. You've got a subscription service here that manages the state of someone's subscription, whether they've signed up, they're brand new, they're suspended because of non-payment, whatever it might be. You have an authentication service here that manages signing up new users and logging them in and validating the requests to the API. You have the messaging service here that sends out emails. So forgot password emails, other transactional emails to users, and so on. You've got multiple services here. Here's the booking service to book your restaurant visit, the claim service to claim your reward, the checkout service here to put in your credit card details when you sign up for your monthly subscription. And all of these work together, like I said. So looking in the IDE, what I can see here, for example, is the subscription service is a good one to take a look at. Because what you see in my serverless.yaml file, and this, there's a lot happening here, so don't be scared off, because these things you build up over time as you need the features. But there's quite a lot of Lambda functions sitting around here, and one of the things you can see is, for example, here's the HTTP function that we saw before, looking pretty much exactly the same as what I defined. This is a production level definition of an API gateway. Here's the circle, draw the rest of the cat. It's exactly as I showed. But there are other events that I'm using. So SNS is a very popular one. Usually with a microservices architecture like this application, you avoid direct communication, synchronous communication between your services. And the reason for that is it adds latency and unreliability. Whereas if you use mechanisms like SNS, SQS, and for anybody who doesn't know, SNS is a pub/sub service in AWS. It allows you to say, I have a message that I want to send to people. When the authentication service creates a new registration, it's going to publish a message into this SNS topic defined here to say, here is somebody who's just registered. And other services can say, I am interested in that message. So they subscribe to the message. So it's a publish-subscribe model where the authentication service will publish a new registration message and the subscription service is listening for a new registration message. Pretty cool way to do things. And this is useful because this increases reliability of your application. SNS manages all the retries and everything for you automatically, which is pretty cool. But this means that my Lambda function is now being invoked by SNS, not an API gateway, which is pretty cool. There's other features here, like I mentioned the DynamoDB example. So here I have a Lambda function that is being triggered when my DynamoDB table is edited. This Lambda function executes, and I can tell you that inside the Lambda function, it sends a message into SNS for all other services that might be interested. And here is a schedule event to go ahead and send a daily subscriber update to a third party to share, because they provide the ultimate reward service, so they need an update on all the users that have signed up, and this happens every day at 1 a.m. So there's a multitude of these services that you can combine together in many ways. You can add whatever services you need. There's another schedule here. I'm just trying to find there's another different one. So that looks like that's for this service. That's what that is made up of. And that you'll find that most of your services will often have a mixture of these. And the authentication service looks very different to that even. So there's even more items here. Here's a more expanded HTTP definition. So you can go into absolute detail with how you want to specify your endpoints. It's not absolutely necessary. Does that help answer the question? Did that help a bit?
Yeah, totally. It's cool to see the kind of different projects with serverless.yaml files. I didn't really realize that that's a viable way to go about doing it with multiple. It's almost like multiple applications, but they're microservices.
Yeah, well, microservices are cool, or most people. It's like microservices are really cool, except if you have to actually configure all the underlying infrastructure yourself. That's usually the annoying part of microservices. I have to manage these containers and the Kubernetes configuration and the load balancing and the deployment. That is really a bugbear with microservices. But thankfully, when you're building things through serverless, the fact that you don't have to worry about that helps a ton. So that helps out a lot. And just to point out, I mean, you're talking about seeing an actual production application. This is the dashboard that we see here is actually a serverless application as well. We use the dashboard to monitor the dashboard, for example. There's a ton of stuff that happens here, and I'm going to go to a busier function to take a look at here, because the dashboard is a pretty complex serverless application that does a lot of stuff. And I'm not doing this to sell the dashboard. I'm doing this to point out that the serverless framework can do a lot. On the wrong service here. There we go. There's a lot of stuff happening. You can code all sorts of things. I mean, the dashboard itself is handling 3 million requests in the last 24 hours. That's the Lambda invocations that we're monitoring at the moment for everybody, just in this specific instance, sorry. There's a ton going on. that you can build with the serverless framework. It is actually a full, complete replacement for how you built applications in the past. Has anybody got any other questions? I don't want to just hog the time talking because I'm so excited about the serverless framework. If anybody has a question that thinks this might be controversial or scare off the speaker, please feel free. I want to answer all and every question, and I'm not afraid to handle something that somebody might have a counterpoint to. So please feel free. You can just do it in text as well if you don't want to speak openly. Okay, nice question. Does it support other cloud providers? Yes, it does. GCP support is unfortunately limited, and that's mostly because of how Google are handling this entire sort of serverless way of doing things. Funnily enough, our Knative support is better when it comes to Google than necessarily GCP and Cloud Functions. I know that sounds weird, but Google, it's mostly just because of Google themselves have put a lot more effort into their sort of Kubernetes ecosystem than the serverless Cloud Functions side of things. Azure Functions is pretty well supported in Node. I think they're busy working on their Python support right now. And in fact, the team from Microsoft built the integration for Azure themselves last year. They did like a rehash of the Azure integration. So that does exist. And there is a blog post about that. So if you go to serverless.com/blog, you should be able to find a blog post written by the Azure team themselves about using the Azure plugin to speak to Azure. But one thing I can actually show is that there are more than just those providers as well. We recently had an integration with Tencent as well, funny enough. They approached us and wanted to have a serverless framework integration into their cloud solution. And I'm just trying to find that in docs. And Serverless Framework has an enormous amount of documentation. So if you just go to serverless.com/docs, there's a ton of documentation there. And I'm trying to see where our list of providers are. Oh, there we go. So you can see there's AWS, Azure, Tencent, Google, Knative, Alibaba, Cloudflare, FN, Kubeless, OpenWhisk, and SpotInst. So there you go. There's a ton of providers that you can take a look at to suit your needs. Anybody else have any other questions? Okay, have you had experience introducing a Lambda function into an environment? Thinking of trying serverless for a cron job, but not sure if it'll be worth the extra setup in AWS. No, sorry, this is a dumb question. Not at all. So the really cool thing is that you don't need to worry about existing infrastructure. So let me read that fully because I just realized this was sent to me privately. The question is, have you had experience introducing a Lambda function into an existing prod environment? Thinking of trying serverless for a cron job, but not sure if it'll be worth the extra setup in AWS Lambda. Sorry if this is a dumb question, and it's not. This is how most people get started with serverless. They will find some low-hanging fruit, something like, and I mentioned this in the talk as well, where a cron job is a great way to get started, just sort of touching putting your toe in the water. Because of the way that the serverless framework builds a stack. So I'm actually going to go to CloudFormation here and show you. What happens is when you deploy with the serverless framework, you create a stack. And here you can see contact service Gareth. And this is a separate CloudFormation stack from all your other infrastructure. It doesn't touch any existing infrastructure at all. And in fact, if you tried and you ran a serverless command, that will throw an error at you to say that CloudFormation resource that you're trying to create already exists. So it won't change anything like that. And this means that there's no additional setup. There's nothing you need to worry about. You can literally just go to run the serverless command, bootstrap a new project, write your Lambda function using the cron job as an event, use serverless deploy, and you're done. There's no setup. There's nothing you have to configure in AWS. These features are all available by default. You just deploy and up it goes, and that's it. You're running your Lambda function. It starts executing your cron job. One way I know a lot of folks end up playing around with things is they will go to the Lambda service and they will use that. They will deploy without an event. So you'll have this code here and people take the event out. And you can just deploy the function just like that. It'll still deploy a Lambda function into AWS. It just will never get triggered. But then that means you can do something like go to the Lambda service yourself, open up a Lambda function and actually test it manually to make sure that it does what you want to do before you make it run every minute, potentially. So that's a great way to get started as well, is just to manually, or use Studio as well. Actually, I just realized Studio has this feature that you can just directly invoke a Lambda function and pass a manually built event object if you like. It's pretty cool. Hope that answers the question. I think that is everything. Unless somebody wants to just click raise a hand or something like that to say that they're busy typing.
I've got a question. Would you be down to do future serverless talks in coming months?
Yeah, I've got no problem doing that at all. I'd love to.
Nice.
You'll
give everyone a chance to play around with it and stuff, and come with more questions to another one.
I just see there's a couple more questions just quickly popped in. I'm going to answer them very quickly. Is there an intro tutorial? Yes, there is. If you go to serverless.com/learn, and this is still being built. So the last few videos of this course are still being produced by me. But if you go to serverless.com/learn, you'll see there's a course that I've created here. There's another one that focuses more on the front end side of things. So if you want to see how you can deploy front ends using serverless, the Serverless Framework can help you do that. But there's also a course similar to the demo that I've done today that goes through a lot of what we've done. And I can just actually drop this link straight into the chat for everybody who's interested in that. To everyone. And that's a nice way to get started. It walks through all of this, setting things up, explaining what serverless is, and so on. So hopefully that answers that question. Is it possible to not have to be married to Amazon and use Postman/Codium for development? Absolutely. If you're only doing, well, married to Amazon, I mean, the Studio thing that I demonstrated has got nothing to do with Amazon at all. This is built by the Serverless Framework. It's part of our Pro offering that has a free tier, so you can use Studio for free. There's no cost to it. And this is just a way that we found to try and make it easier for you to execute your Lambda functions in a sort of semi-local environment so that you edit locally, save your file, and within seconds it gets updated into AWS for you so you can continue to test. But you can use Postman, absolutely. API Gateway produces an HTTP endpoint. It doesn't care what you use to call that endpoint with. You can use whatever tool you want to test your endpoints with. The advantage the Studio gives you is that it lets you invoke other functions as well, triggered by other events. So if you have SNS events, DynamoDB events, cron jobs, you can still trigger them through Studio and test them in that way, which is pretty useful. What would be a good way of understanding all the various AWS components needed to put together a serverless architecture? So there's a lot of really good resources out there about these various AWS services. So the general way that I look at building a serverless application is I need to decide my features. And I'll say I want to do X. Is there a service that'll do that for me already? So one quick example is if I want to do text or speech to text conversion, if I want to do that kind of thing, I'm not necessarily going to look at building an application that uses an AI model, blah, 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 that does that. I'm going to see if AWS has a service that does that, and they do. And so that's a very quick way for me to just to get the feature set that I need without building it all myself from scratch. If I need file storage, I'm not going to start trying to figure out a way to create an EFS thing on an EC2 instance. I'm just going to use S3 because that already exists. I can store files in S3. And the one downside of AWS is that it has an enormous set of services to look at and use. I really can only recommend that you try to do a bit more research. You can often just Google things like AWS file storage or AWS text-to-speech or whatever it might be, and that'll help you. And really, it comes with time. It comes with playing with these things, experimenting with them. A lot of the time, I used to build things from scratch. I built an authentication service myself and then I found out that Cognito exists, which can do that for me. So you just get used to them. You start experimenting and playing around with them and just researching, essentially. Will it be possible to do further videos that are a bit more advanced, maybe looking at other frameworks like SNS? Yeah. I guess that's what Connor was alluding to, maybe a slightly high level thing of putting together an application that's a bit more advanced. We can definitely do that. Yeah, we'll just have to talk about when and so on to work that out. Steve asks, how long is the Pro free trial? It's indefinite. There's no time limit on that. There's just a limit in the resources allocated to you. So we try to make it enough so that you can play around as a single developer. But we unfortunately it does cost us to run the service, so we do have to have paid tiers. And it's a very generous free tier, so there's a lot of capacity there for you to play around and get used to it. And Studio is free, and if you just do basic dev work, you'll never ever reach anywhere near the limits that we have on the free trial. Okay, I've answered them really quickly. And I guess the last thing I want to add in, if you get a chance to play around with serverless, I would highly recommend taking a look at the dashboard in a lot more detail. I mean, that on its own is a talk I could do for 2 hours because of the feature set that's available with Serverless Framework Pro dashboard. It has a lot of stuff available for you to help build and manage your serverless applications. It's really a lot to go through. We often have 2-hour calls with potential customers on that. So it's quite a beast. So I can't go through in detail today, but we saw a little bit of a taste of that. It's got a lot of really cool features to help make your serverless development a lot easier. I think that's it, Connor. I think.
Cool, excellent. Thank you so much, Gareth, and hopefully you can enjoy your morning coffee now.
Yeah, it's going to be time for my second cup.
Nice. There you go.
Thanks so much.
Yeah, totally. So I am going to stop the